Hello everyone, welcome to an algebra video tutorial with exponents. We are learning in this video about the product property of exponents. What that is basically what happens when we multiply with exponents involved. So here I've got some examples that we're going to work through. We're going to work through these in expanded form and look at what's happening in the patterns, and then draw kind of just a general conclusion for what to do in case we ever encounter multiplication problems with exponents. All right, let's start with the first one. We got 4 squared times 4 to the third power. So we're going to write it in expanded form. Let's see what we got here. So 4 to the second power is just 2 4s multiplied. So I can write that as 4 times 4. But then I'm also multiplying by 3 more 4s. 4 times 4 to the third power is 4 times 4 times 4. So I'm going to write that in expanded form. So we got 4 times 4 times 4. Well, let's see what we have now. So we've got 4 times 4, but I'm multiplying by 4 times 4 times 4 times 4. Altogether, we've got 5 4s multiplied, right? Well, how do we write that? What's a shorthand way of writing multiplication? Well, 5 4s I can rewrite as 4 to the 5th power. Well, that's interesting. If I wanted to calculate that out, that's just equal to 1024. Let's take a look at another one here. Let's do y times y to the 7th. Now, there's no exponent here. So you say, well, where's the exponent? How am I multiplying exponents? Well, I can think of this as just one y, right? So if it's helpful, go ahead and write a little 1. That's the same as y to the first power. When a number or variable is all by itself, it's just to the first power, just one of them. So this is y to the first power times y to the 7th power. Let's write that in expanded form. So I have 1y, and I'm multiplying that now by 7y's. So let's do 1, 2, 3, 4, 5, 6, and 7. Well, now how many y's do we have all together now? Well, we've got 8 of them. So it looks like I could rewrite all of this as y to the 8th power. Let's do one more example here. We got x now. I've got x to the 9th times x to the 4th. Let's write it in expanded form. I've got 9 x's. This is going to be fun. So x times x times x times x. 4, 5, 6, 7, 8, 9. X is all multiplied together. Multiplying by 4 more x's. 1, 2, 3, 4. And if I count them all up, we have 13 x's. So I can rewrite this then as x to the 13th. Now let's point some things out here. Here we had 2 4s multiplied by 3 4s, and we ended up with 5 4s, right? Here I had 1y times 7 more y's. We ended up with 8 y's. And then 9 x's times 4 more x's. We ended up with 13 x's. The whole pattern to get from here to here is just to add the exponents. It's essentially what we're doing. We're adding two groups together to get the total. So in general, let's form a general statement now. If I take any base, b, and it's to some power m, so I'm being very general here, b and m could be any variable or number, and if I multiply it by the same base, but is a different exponent, b to the nth power, the result is I will have b, but I'll add the m and n together. So it'll be to the power of m plus n. Notice I want to point out that this only works if you have the same base. So notice b and b are the same. We did 4 and 4. We did y and y. We did x and x. One common mistake students will make when doing exponent properties, that's a horrible line, but anyway, hopefully you get the point, they may see something like this, like 4 to the third times 2 to the seventh. So they say, okay, well, 4 times 2 is 8. And then 3 plus 7, because I can add the exponents, that makes 10. So the answer should be 8 to the 10th, right? That is incorrect. You got to think about what exponents mean and go back to expanded form. This is a bunch of 4s, so it's 4 times 4 times 4 times a bunch of 2s. So you kind of do get some 8s. There's 7 2s. 4, 5, 6, 7. But that is not the same as 10 8s all multiplied, right? 8 times 8 times 8. You can clearly see we're going to get two very different numbers when I write them out in expanded form. 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. So no, these are not equal. Don't do this. But there you go. There's an introduction to the product property of exponents. If you're multiplying the same base, you can add the exponents together to get the resulting number or expression.